Hello students, welcome back to the fifth video of this playlist. So in this fifth video of playlist, we will be solving question number 5 of June 2024 P4 paper. So basically question number 5, it's from it's a mixed question, it's from parametric equations and also from integration of parametric equations. So you can say this is a mixture of parametric equations and integration. Okay, so let's get started with the first question. Number 5, you can see a figure number 2, you can see on the screen. So on this figure there is a parametric curve has been given. The graph of a parametric equation is given. So the parametric equations which defines the sketched graph, they are defined by x equals to t square plus 2t and y equals to 2 over t times 3 minus t. Okay, so this curve is defined by the parametric equations x and y. That's fine. So we know that parametric equations have their separate equations for x and y, right? So where the range of values for t, it's given in terms of a and b. Okay, where a and b are constants, that's fine. The ends of the curve lie on the line with equation y equals to what? Y equals to 1. You can see that the line, horizontal straight line y equals to 1, it intersects the parametric curve at t equals to a and t equals to b. So the first question in part A, it's asking find the value of a and the value of b. We need to find out the value of a and b. Okay, so for finding the value of a and b, so we know that the value of y is known. Y is equals to what? 1. So let's substitute y equals to 1 into the parametric equation. So the parametric equation for y is what? Okay, it is 2 over 3t minus t square. Okay, so 2 over 3t minus t squared, this is given as what? This is equals to 1 because they are intersecting at a and b. The line y equals to 1, it intersects the parametric curve at a and b. Okay, so now cross multiply, you will get 2 equals to what? 3t minus what? T squared. Okay, now take everything to the same side, you will get t squared minus 3t plus 2 equals to what? Equals to 0. Okay, now we need to middle term it, so you will get t minus 2 times t minus 1. This is equals to what? This is equals to 0. Okay, now either we will get the value for t, it is what? Either t is 2 or the value for t is what? The value for t is 1. We got the two possible values for t. So if t equals to 2, what would be the value for x? Now we have to put those values of t into the equation of parametric equation of x to get the value of a and b. So if t is 2, then x is what? 2 square is 4 plus 4, this is 8. X is what? 8. And if t equals to what? 1, then x equals to what? T square, 1 square, this is 1 plus 2, this is what? 3. So the value of a comes earlier, so a is what? 3, and the value for b is what? The value for b is 8. B comes later, so b is 8. That's it. We got the value for a and b. This is basically the range of t. Okay, so next for part B, the region R shown shaded in figure 2 is bounded by the curve and the line with equation y equals to 1. Okay, we can see the region R is bounded by the line y equals to 1 and the curve, the parametric curve, and t equals to a and t equals to b. Okay, so show that the region R is given by the region R, the area of region R, it is given by what? This equation. We need to show that. Okay, So for finding the area under the curve, for finding the area not under the curve, to find out the area of region R, what we can do? It's for how much marks? It's for 5 marks. So we have to do some workings there. Let's see what are the workings. So to find out the area of region R, we can do one thing, because if you integrate the curve directly, you will get the area under the curve, right? You will get this area. You will get, yeah, the area under the curve. If you integrate the curve, parametric curve between A and B, you will get the area under the curve and the x-axis. Okay, but we need the area between the line y equals to 1 and the curve, right? Region R. So for finding the area of region R, we can do one thing at first. We can find the area of the whole triangle, whole rectangle basically. We can find out the whole rectangle, and from that rectangle we can subtract. We can subtract the area under the curve. This area we can subtract later on from the whole rectangle. Okay, so at first let us find out the area of the rectangle. Okay, so for part B, we will be finding at first the area of the rectangle. Okay, so what would be the area of rectangle? Area under the curve and the x-axis. Okay, area under the curve, or you can say between the curve and the x-axis. That will be better. Area between the curve and the x-axis. So this would be what? Area between the curve and the x-axis. This is integration. How we would integrate? We will integrate from B. B is what? 8 to A. A is what? 3. Which equation we will integrate? The equation y. Y dx. Right? Okay. Now we need to make what? Substitution. This is integration by substitution. So for substitution, okay, you can see that the terms in the integral are all in terms of what? T. So that means we have to convert all of the y and x's here to what? T. In terms of T. We need to represent, we have to make them converted to T. So in order to do that, we can substitute the parameter, the parameter of what? The parameter of y into the equation, okay, into the equation integral. So we will get the what? Get the y in terms of T, done. But remaining is what? Remaining is the dx. So to get the dx, what we will do? We will differentiate what? X, the parameter of x. So what's the parameter of x there? The parameter of x is given as x equals to t squared plus what? 2t, right? So if you differentiate this one, what you will get? Dx over dt, right? Dx over dt. So what you will get? 2t plus what? 2. Now we need substitute for dx in terms of t. So make dx subject. You will get what? 2 times what? T plus 1 times what? Dt. Done. We got the substitute for dx. Okay. So what we can write? So in place of, look, the limits, let's see the limits. The limits 3 to 8. The limits, these are given for x, right? But now we are converting all of the x and y variables into in terms of t. So that means we need now the limits for t now. Okay. So if x equals to 8, then what was the value of t we got? The value of t was, you don't need to show this, you can do it directly since we already did this earlier, right? We got t equals to 2. So that would be what? The upper limit would be 2. We got this in the earlier question, part A, and the value for t, for x equals to 3, it was 1. And in place of y, we will substitute what? 2 over t times 3 minus t. Okay, the parameter of y, 2 over t times 3 minus 1, t times what, 3 minus t, not 1, it's t. Okay, so y, we represented y in terms of t, and now substitute the dx. What we will get? Dx equals to 2 times t plus 1. So 2 times what? T plus 1 dt. Done. We have converted all of the terms, all of the x and y variables to t. Okay. So 2 times 2, this is what? 4. So take 4 outside the integrand. Yeah, we can take 4 outside the integrand and then integrate what? It will be 2 to 1. On the top it will be what? T plus 1. T plus 1 over t times what? 3 minus t. 3 minus t dt. Done. Now the area of region R, right? So area of region R. So what? Region, it's what? The area of region R is the area of rectangle minus the area between the curve and the x-axis. So this is what? 5 minus 4 integral 2 to 1 t plus 1 over what? T times 3 minus t dt. Okay, so that's what they have asked for, right? Okay, done. So we got the value for what? We got the value for k and we got the value for m. M is what there? M is 5 there, and k is what? K is just 4. Okay, done. Okay, now the part C. The part C says write t plus 1 over t times 3 minus t in partial fractions. We need to convert this to partial fractions. So for C part 1, the equation is what? T plus 1 over t times 3 minus t. T plus 1 over t times what? 3 minus t. Okay, so it can be written as what? Partial fraction. So we can write a over what? T plus what? We can write b over 3 minus t, right? Okay, now partial fraction, right? We need to convert it to partial fraction, so we can multiply both sides by t times 3 minus t. So you'll get t plus 1 equals to what? A times 3 minus t plus what? pt, right? Now we will substitute what? At first t equals to 0. We will substitute the value of t such that one of the term gets eliminated. That's why we choose t equals to 0. So that would be what? So 3a equals to what? 3a equals to 1. So the value for a would be what? 1/3, right? 1/3. Okay, we got the value for a, and then put t equals to what? What we need to put then to eliminate b? To eliminate a, we need to put t equals to 3. So if you put t equals to 3, what would be? It will be 3b. 3b equals to what? 3b equals to 4, right? So you'll get b equals to what? 4 over 3. Done. So that means t plus 1 over t times 3 minus t can be written as what? A, it is 1 over 3t, okay, plus 4 over 4 over what, 3 times 3 minus t. Okay, that's it. That's the representation of partial fraction. Okay, now part 2. Okay, so in part 2 what they have asked for, let's see. In part 2 they asked use algebraic integration to find the exact area of R. We need to find out the exact area of R. Okay, so we got the area of region R. It is given by what? Area. The equation for the area, it is given by what? Area equals to what we got earlier, 5 minus 4 integral, the upper limit was 2 and the lower limit was 1, right? If I'm not wrong, the upper limit was 1, yeah, 2, the lower limit was 1. And we have already converted, like simplified this fraction into partial fractions. We got what? 1 over 3, 1 over 3, right? 1 over 3 times t inverse, right? And then plus what? 4 over 3 times what? 4 over 3 times 3 minus t inverse, right? Okay, then dt. Okay, so now we need to integrate it. So if you integrate, what you will get? 5 minus 4, then put the interval like definite integral. So 1 over 3 times t inverse. The integration of t inverse is what? If on the variable, if the power of the variable is -1, its integration is what? ln t, right? Modulus. Okay, and it will be, the coefficient was 1/3, it will remain as it is. Okay, okay, next is integration of plus 4 over 3, 3 minus t inverse. So integration of 3 inverse t inverse would inverse 1 is what? ln 3 minus what? t modulus. Okay, now it is chain rule, reverse chain rule. So integration of 3 minus t inverse 1 is ln 3 minus t. So now differentiate the part within the modulus, you will get -1. Okay, so then use this derivative of the part within the modulus to divide 4 over 3. So we'll get -4 over what? 3. This is the integral. So upper limit is 2, lower limit is what? 1. Okay, now just we need to do the calculations. 5 minus 4 times what? 4 times 1 over 3 ln t. Ln, so that should be 1 over 3 ln what? ln 2 minus 4 over 3 ln 1. So ln 1 is basically 0, so ignore. We can ignore this since it is 0. Then put the lower limit. Lower limit is what? Also 1 over 3 minus 1 over 3 ln 1. ln 1 is 0, so ignore this one. Plus what? It will be plus because from the upper limit, from the substitution of the upper limit, the lower limit gets subtracted. So that should be what? Plus 4 over 3 ln 2. Right, now just do the calculations. We got 5 minus 1 over 3 plus 4 over 3. This is basically 5 over 3. So 5 over 3 times 4, this is 20 over 3 ln what? ln 2, right? It is ln 2. So this is the value of the region. This is the area of region R in the simplest form, and that's the answer. So you can write unit squared since it is what? Area. So this can be written as unit squared. This is the area, and that's the end for the question number 5 of P4 June 2024. paper.